An important element in certain games is the ability to navigate around the world. This usually involves moving a character around the screen and having the camera follow its movements. But what if instead you would like to pan and zoom around the world with your finger or mouse, like in one of my favorite games, Hidden Folks? In this tutorial, I will show you how to build a script that zooms and pans your camera based on touch. Right now in Unity, I have a sample scene set up. I've imported 380 icons using a black and white icon pack and wrote a quick script that when I press play causes them to distribute evenly across the screen. These icons don't serve any function other than give us a visual reference for this tutorial. Now the first thing I want to do is create a function to pan around the screen using a mouse or touch input. So we are going to create a script that when we tap and drag our finger, our camera will move around the screen, exposing more of the scene. We do this by moving our camera in the opposite direction we are dragging, so as to give us a natural panning effect. So then let's go ahead and create a C# script for this, and let's label it pan zoom. Then let's go ahead and create a new vector 3 to store the position of the first instance of our touch. Let's just call this touch start. Then in our update function, let's create an if statement to detect if a touch is started by using get mouse button down. The 0 represents the left mouse trigger, but it also renders true if a touch is pressed down on a touch device. Then let's set our touch start position to equal the position of this start in world space. We use screen to world point to convert our touch position to a world space coordinate. If you'd like a better explanation on screen to world point, check out our mobile joystick video where we discuss it in depth. Next, let's create another if statement, but this time let's check to see if a touch is being pressed down. The difference between this if statement is that this returns true for the entirety the touch is pressed down, and the first if statement is only true on the start of the touch. So then let's calculate the direction the mouse has moved since we first started the touch. We do this by creating a new vector 3. And then we want to subtract touch start by the mouse's current position in world space. And then we just need to add our direction to the main camera's current position. Let's go ahead and save the script and go back into Unity. Then let's drag our script onto our camera's game object and press play. If done properly, we can now click and drag to move around our scene. Now we are going to set up a function to zoom our camera. We will ultimately do this by adjusting our camera's orthographic size value. For a more in-depth explanation of what orthographic size is, I recommend you check out my video explaining orthographic size. First, we are going to create a simple example that uses our mouse's scroll wheel to zoom in and out while clamping it to a minimum and maximum zoom value. If we go back into our script, let's create two new public floats. One to store our minimum zoom out level, and another to store our maximum zoom out level. I've made them public so you can adjust these values in the inspector for whatever value works best for you. Then let's create a new function that will adjust our orthographic size. Let's go ahead and label this function zoom, and let's pass a float to it called increment. Then we need to modify our camera's orthographic size. We will use math.clamp to clamp our new value between two numbers. For our value parameter, let's subtract our current orthographic size by our increment. Then let's use our zoom out min and max values for our clamp boundaries. This basically clamps our orthographic size so that you can't zoom in or zoom out further than the values set by our zoom out min and max floats. Then in our update function, let's declare our function called zoom, and for our increment parameter, let's just use the mouse's scroll wheel. If you scroll backwards on the mouse wheel, it will give us a negative increment and vice versa for a forward scroll. So then all we need to do then is save our script and run it in Unity. you should be able to zoom in and out using your mouse's scroll wheel. Unfortunately, this works great if you're using a mouse, but this code will not work on a touch device. So then what we want to do is write a function that works with a mobile or touchscreen device. Common functionality for touch devices when it comes to zooming is to use the pinch technique. If I pinch my fingers together, the scene zooms out, and if I move my fingers in the opposite direction, the scene zooms in. We will calculate this by storing the position of our fingers and comparing the distance between movements. So let's go back into our editor and let's create a new if statement above our get mouse button down statement. This time we want to check to see if there are 2 touches detected on the screen. We can check this with input.touchCount. Then we are going to want to store both of these touches. Let's label these touch 0 and touch 1. Next, we need to compare our current touch position from our last touch position. To find our last touch's position, we'll use delta position. And we need to do this for both of our touches. Then let's store the magnitude of our previous position in a float called previous magnitude. Magnitude calculates the length, or in this case, the distance between our points. Then let's calculate the distance between our current position. Then to find the difference, we subtract our current magnitude by our previous magnitude. So then let's declare our zoom function, and for our increment, let's multiply our difference by 0.01. We multiply this value to slow down the movement of our zoom. I use 0.01, but feel free to adjust this based on your preference. Lastly, let's add an else in front of our if statement below so that we can prevent the ability to pan if 2 fingers are on the screen. So then if we export this build to a mobile device, we should be able to smoothly pan around the screen and use our pinch to zoom technique to zoom in and out. If you found this tutorial useful, be sure to give this video a thumbs up and subscribe to this channel for more videos like this one.